It's day 591 off the grid, and yes, today I've actually got back to doing something which is kind of relevant to the title of my blog, doing something to do with off-grid power. And this is what I've done today. I've finally got round to casing a charge controller here. Now this charge controller is actually, well, it's not the very first charge controller I built. Those voltage sensitive relay circuits, which I still use a lot of, preceded this one. But when I had my first 10 watt solar panel up here in Shannon and a few 32 amp hour gel batteries, which have sort of sadly demised all but that's another story, I needed a charge controller, so I built this one. And instead of, you know, using a simple and common design, I decided to reinvent the wheel, as it were, and built a charge controller which works on a Negistor principle. And that transistor down there functions as a Negistor. So it's basically a threshold device. It kind of works like a relaxation oscillator, just like when you have a neon and a capacitor kind of thing from a high voltage power supply for a resistance. It just, when the voltage builds up to a certain point, it avalanches and causes something to happen. In this case, what happens is that the drive to the main power transistor here gets removed. So therefore it regulates. It's basically a sort of a free running switch mode, really. You could almost call it a hit and miss type arrangement, but switch mode sounds more professional, but that's what it is, and it does work, and I did use it until eventually I started, you know, using commercial charge controllers, and then building my own linear ones and different things. But I've had this going for quite a while to just charge up random batteries here in the shed, but I thought this would be just the thing for my 10 volt battery bank, because since it's homemade I can adjust the parameters to suit what I want to do with it. And in fact I have. There used to be a red LED there in series with the green one, and that was to make the threshold voltage about right for a normal 12 volt battery. I've removed that to drop it by a couple of volts, so it's more in the range now suitable for the so-called 10 volt battery bank. And of course you can trim it using this trimmer here. But what I've done with it today is I've cased it up. So I bought this case a while back from the warehouse. It's just a domestic kind of click-clack bin kind of thing, or the modern version of the click-clack. It's called a Systema. But they are quite watertight, and that's important because I'm going to need it fairly watertight where I'm going to install this ultimately. So I've mounted up the power transistor here on the heatsink. Shouldn't need a heatsink that big because it is after all switching, but then at the same time this is a bipolar transistor, because at the time I built this I wasn't comfortable with MOSFETs, so I just built it with techniques that I knew, and I knew bipolar transistors, so it's a switching type device using a bipolar. So I've just, you know, put the transistor in there, mounted solid, and the circuit itself, and this circuit breaker here is the battery circuit breaker where the batteries will come in, and a terminal block here to aid in connection of battery in, load out, and solar charge in, which will come down this red wire, which it is at the moment. I've just been able just to fit in at the end of the day. Look at it out there. As you can see, the long shadows there. The sun's just about setting. I've just been able to squeeze a little bit of power out of my 10 watt SolarX panel to test this with this ancient little SLA battery, which is actually completely fucked. I could have just used a capacitor, just something hanging off the end there. But it's working, and I can adjust the threshold within the range that I want it to be. So tomorrow, or maybe the next day, I'll get on with it and actually install this on the 10 volt circuit. I was thinking about lots of different ways of actually charging those 10 volt batteries, including AC coupling, basically plugging in a mains battery charger into one of the inverters and maybe controlling it so it only came on a sunny day, something like that. Another way was to just piggyback it off one of the other battery banks, but with some isolating diodes and voltage dropping diodes, so it would never charge beyond what a 10 volt bank needs to. A lot of those ways of course have drawbacks, but I thought, well, the best way at the end of the day is just to give it its own charge controller. I did think about giving it its own solar panel as well, which would have given me a lot more latitude to what charge controller I could use, but I kind of thought that's a waste, because most of the time this battery bank's just going to be sitting there topped up, and I'd rather that solar panel was connected to my main system helping to do some work, so in the end I'm just going to take this off the main system using probably some kind of low voltage bulb as a dropper, like I've done with other arrangements, so it won't pull so much current that it will destroy itself. It'll just keep it in check. I only want about 2 amps maximum to be the charge current here, because it's just basically a topping up kind of job, well, keeping the batteries topped up, because these batteries get little use, so there's long periods in between when they're actually called upon to be used, so a fairly low charging current is fine to bring them back up. They're basically all sealed batteries. Some of them are flooded, but they're all sealed batteries of one type or another, but so we don't want to be boiling the shit out of them anyway, so I can just adjust this to suit. I mean, you never know what's going on in a 10 volt battery anyway, because what I call a 10 volt battery is simply a 12 volt battery that's lost a cell or something. You don't really know whether it actually just lost a cell or whether several cells are getting lazy. You don't really know what's going on in them, so it's kind of a bit unpredictable. But for doing things like this, you can make use of those batteries that would otherwise have to be almost instantly scrapped and get a bit more life out of them. So that's basically it really. I'm actually surprised that we're still seeing the LED winking away. And yeah, I don't think there's anything else to say about it really. I decided to go for it, and that's the thing. I've got this saying, Zan doesn't fuck around. Well, I don't know if that's completely true, but once I make up my mind to do something, yeah, then I don't fuck around. I get onto it and do it. So started this afternoon, and at the end of the day I've pretty much got this ready to mount. Just got to bore a couple of holes in the bottom here for the cables in and out and stuff and that kind of thing. I'll mount it up, connect it to the 10 volt battery bank, and then decide what kind of resistance to use to supply power to it from the main array. And that's basically it on day 591 off the grid.